want to talk about shift register. And that shift should be left, right? So what it means, shift left, that means you have one 4-bit shift register. This is 1, 2, 3, 4. So you have one actually serial input. You could actually give one input from the left side, okay? So in the first, if your shift register is sensitive to the rising edge, in the first actually rising edge, you actually get your bit here. So that means it's actually whatever you have here will be actually moved to here. Whatever you have in this part will be moved here. Whatever you have here, it will be actually moved to this part. And what you had in the last section, it will be gone, okay? So this is actually exactly opposite of the shift right. In the shift right, the serial input was here. So in each actually rising edge, it's actually shift 1 bit to the right. Here is exactly the opposite of that. We want to use the D flip-flop and design a shift register. So definitely you need 4 D flip-flop because your shift register is 4-bit. Okay, so I actually put 4 D flip-flop here. So all of them is D flip-flop. So what we actually use the rising edge flip-flop. So that means this is a clock. This is a clock. You see this symbol here, which is says these are the sensitive to the rising edge. So we actually connect. This is maybe the most obvious part of the design, right? We actually you actually connect the old clock pulse and call that the shift register's clock pulse. So what we need to do for actually each of these inputs, so D flip-flop has one input. Whenever that is 0 and it's actually is a rising edge, it's actually, if this is 0, the output will be 0. If this is 1, it should be 1. Somehow it's actually move or keep whatever you give as input, right? So based off what you want to design, so the serial input should be actually entered from most right one. So that's the reason. So definitely you should put the serial input from here, which is the new one. So you give a new value for D. What should happen to the old one, right? So whatever you have here as a old value, it should be actually moved to here. So that means the output of this should be connected to this. What should be the value, old value of this should be goes to the next. So that means this output of this should be connected to this. So what should be happen with the old value of this? So this actually comes here. Whatever you have here should be actually go back to here. And definitely whatever you have here, it will be actually gone, right? And it's going nowhere based off this design that you want, okay? So you could actually give a name for each of them. The output here is Y3. You could actually consider this as an output. It is Y2. So you could say this is Y1. And the same thing you could see here, Y0. So if you label the same thing here, Y0, Y1, Y2, and Y3. So just check the truth table of the D, then you could understand why it should be worked exactly with this. So whenever first rising edge comes, so you got this input, it is here, and the old one actually connected these here. So that means The new value for this will be the old value of this because you connected these here. So that means this is exactly what happened. Whatever you have here, move here, and the same thing for the others. Whatever you have here, move here, and whatever you have here will be in the last one, and the last value will be gone. So you could actually simulate this on the Multisim. The simulation maybe is more clear what I'm talking here. So let's to actually back here and let's to actually make this a little bigger. So okay, just a little zoom. Okay, so see, this is what we have here. So this is exactly the same thing. See, I use for D flip-flop, the all clocks actually connected to each other, and they are connected to the clock pulse. So I just forget one thing in our design. So let's do back to the design. That actually is a clear and set bottom that we have on the flip-flop, right? Remember we talked about the some pins, which is the clear CL bar, and we have another pins on the any flip-flop, which is preset PRS bar. So whenever you active these two, which is the bow space of this circle that you see will be active with 0. So if you active the clear, the output will be 0 no matter what you have as input on the flip-flop. If you active this, the output is 1 no matter what you have on the clock and your inputs. So we actually say usually you have one initialize input, we say INT bar. So which is we connect all of these clear pins, okay? So whenever you want to start to work with this shift register, you just active this for a short time. So that means you put initialize with the all 0, then actually it start to do its own job. That means for the short time, you just active, then actually it's deactive. For the preset, we just connect them to the VCC because we are not going to use them, just deactive them. So that's the reason I connect all of them and they connected to the VCC. They do nothing in this design, okay? So we did the same thing in the simulation, okay? So see the start with the clock, the all clock pulse connected to each other, connected to the function generator, give a square wave, and the frequency is 0.5, okay? So see the preset, this is a preset, then the IC number for D is 7474N. So you see this preset PR. So the preset is connected all together and connected to the VCC. This is, we had the same thing in the design. So the clear CLR is these pins, connected all of them to each other and connected to one switch, which we call that initial pin in our design, right? I just for a short time, just whenever I want to start to work, put that 0, then back to the 1. This is what we need to do. So then see what else we have. This is shift. Yeah, this is sorry. This is shift right. We need to check shift left, which is the same thing, same explanation. So the clear is connected to the CL bar pins connected all together, which is then connected to the initialize. So the preset connected to the VCC. I already explained that. So see the serial input. So this is what we have in the design, right? Connected serial input from these D flip-flop. I connected that to the switch, which I give to give a 0 or 1 as a serial input, right? So the output of this connected to the input of this, similar things we have here on the simulation, the output of this connected to the input of this, and the output of this connected to the input of this. And this one is connected to nowhere because its value it will be gone, okay? So let's to simulate that and see, could we see that actually shifting the left. So what I'm going to do again, this is the initialize. I'm just push that for a short time, the whole thing is 0. Just give a 1 in the short time, then put that back to the 0. So see, it is exactly working that way. I give 1, so whenever it see any rising edge, it's actually moving. The next rising edge is here, next rising edge is here. So let's do that. I just put that on and off. So let's do that again. So just for a short time, 1, then back to, so see, it's actually move over there. Okay, so repeat that again. So just 1 here, here, here. If you want to do that more slow, so you need to actually have big time difference between the two rising edge. How you could do that? You change the frequency. If you have smaller frequency, it means you have bigger period, so that means it should be that shifting to the left will be more slow. So I changed that to 0.2, 0.5. So definitely should be more slow. So again, I initialize the circuit, give 1, then turn that back. So see, this time is more slower. Shift to the left, shift to the left, it should be gone. That's gone. So if you actually again put 1, so then put the 0, so this actually move here, then should be here, then should be here, then will be gone. Okay. So depending on how fast you want to this shift, definitely you could actually change the frequency of your clock, and it's definitely will be actually change the actually the shift speed. So let's do that for just one more time. So you have 1, so it's actually shift left, and shift. Okay. So this is the shift register, and this is how you could design a shift register that able to actually shift to left.